So just before the break, we were talking about binary decimal calculations. We're talking about different types of IP addresses and classes. And obviously, we talked about subnet mask and how that's used to determine if a computer's on the network or not on the network. So let's just, because we talked about that, let's actually quickly remind ourselves something that's in the assessment. Okay, so the aim is to get through this subnetting today, but if we don't, we have a bit of time up our sleeves next week. So that's where we can use the time as well. So as we left for the break, there was a few things. We talked about the idea of these /8/16/24s, meaning that that's the length of the subnet mask. 8 bits, 16 bits, 24 bits, and you can see it's nicely on those borders. Okay? And basically what that means is that if I have a /24, it means the first 3 octets of the subnet mask are all ones. And the last octet is 0. And it also means, sorry, Lauren, I didn't hear you. It also means that the first 3 octets are the network portion and the last octet is the host portion. That's nice and easy, and we can just apply an IP address and put that subnet mask, and we can turn a Class A into a Class C effectively by just using the Class C subnet mask. So do you remember what was the default Class B subnet mask? Which one of those 3 is the default Class B subnet mask? Sorry? 16, correct. So why am I asking you that? Because basically when I say Class A, Class B, Class C, first of all, you have to recognize what IP address is which class and what is the default subnet mask. And then we can determine how many bits we need to borrow to achieve the results we need to get. If you don't know that, then it's gonna be kind of hard. Because if you start off with a Class A IP address and you think it's a Class C, then you're going to borrow a different amount of bits than if you were a Class A. All right, let's get into that borrowing bits and subnetting. So let's just get a new example. So let's just grab this and go to a new worksheet again. I seem to be doing this a lot. We'll put it here. And we'll just delete all of this. And we'll possibly add another one as well. But we'll see. All right, so if I give you an IP address. Okay, so first of all, class. Second of all, default subnet mask. Yeah, so we'll format that a little bit better. And we'll go, yeah, okay. So then we'll go, yeah, we'll start with that. Okay, so if I give you that, what class is it?
Class A.
Class A? No.
Class C.
Class C, correct. Okay, so because it's within the range of, yeah, remember Class C, between those 2 numbers. Class B, so between those 2 numbers. We're looking at the first octet, by the way. Okay, Class A, those numbers. All right, so Class C, what's the default subnet mask of Class C? Sorry? Did you say something? 255. 0?
Yeah.
Yeah, okay, so basically that's from what my friend done it. Okay, let's do it with that, /24, which is going to be equals to 255.255.255.0. Okay, let's actually make that a little bit wider so it's pretty obvious. So everyone agrees that one is a Class C and that's the default subnet mask. So what is the network ID then of that IP address? .28.0. Okay, so I am obviously not everyone wants to talk and not everyone wants to contribute, and that's fine if you're shy, but I also wouldn't know if you understand it or not. That's the problem, okay? But basically, if you remember from the first lesson, if you position that IP address over that subnet mask, anything that's over the 255 drops straight through. Yeah, sorry, I typed that wrong, didn't I? And anything that's sitting over the 0 is blocked and becomes 0, okay? So this gives us what's called n.n.n.h. You're probably wondering, what the hell is he talking about, N and H's? What do you think I mean? Yeah, that's right. N equals network bits or portion. And H equals host bits / portion. So let me just format the cell again and make it wrap. And format the cell and make it wrap. All right, so basically when I say n.n.n.h, that means the first 3 octets are the network portion, and that last octet is the host portion. You know that from basically the subnet mask and the IP address, and you get the network ID, right? So what does that actually mean? To be on the same network, the first 3 octets must be identical, but the last octet, which is the host portion, can be different. So far, so good? All right, so let's keep on going. So that's what, if I give you that number, that's kind of information that you should be able to generate straight away from the top of your head. That's the level I'm after. That's a level we're expecting at this set 4 level. If you can't do that now, it's not the end of the world, but you eventually need to do this before you move on to the diploma. All right, so that's what you can generate. That's fine. So can anyone tell me how many hosts I can have on a Class C network?
Is it only 256?
254. Okay, so don't forget, there's a network ID, which is .0. And let me just move this all down a bit. And there's also what's called a broadcast, which again is something you should know. 192.168. I'm so used to saying 192 because that's my examples. .255 is the default broadcast. So there's 2 numbers, 0 and 255, can't be used for IP addresses because they represent the network and they represent the broadcast. So if you actually have this 8 bits, the maximum number of possibilities is 256, 0 all the way up to 255. But 2 of them, this plus this, is used. So number of hosts, and we'll just put this down here again. And we'll format that better. Probably should just make it wider, to be honest. And that's going to be 254 hosts. Okay. So we'll just undo that. All right. So you notice I've got this sitting right there, ready to go any time, okay? Because that's what we need. So again, all of this information that I've got here, I derived just from knowing it's a Class C IP address. All of this. None of this is given to me. Everything is derived from my knowledge of IP addressing. Okay, that's good. So what if we say, hey, I don't want to have 254 hosts. I want to break it up into like 5 different networks. Interesting, right? What if I don't want 254 because that's too many IP addresses on this network, or too many broadcasts or whatever, or I want to make it into 5 different networks because this is a public IP address. It's not, by the way. It's a private IP address. I know that because it's no, this is a public one. This is a public one. If it was a public one and we're configuring on the internet, I don't necessarily want to use up all 254 IP addresses because that's a waste, isn't it? So therefore, remember I said public IP addresses are worth money. If I'm wasting them because I need 5 IP addresses, let's say, and I'm giving myself a Class C subnet mask and I'm getting 254 hosts, I'm really just wasting 249 IP addresses. And I could sell them, couldn't I? So let's say I want to make this smaller. I can approach in 2 ways. I can work out how many networks I need or how many hosts I need. Let's start with the number of networks. So let me just write something down here. Sorry. So number of networks, okay, so hash stands for number, okay, equals 2 to the power of 2. Sorry, not 2 to the power, 2 to the power of n. So let me just double check my, where n is the number of bits borrowed. So I might just reduce this a little bit. And I might just make this a little bit wider because it looks like, so I am going to make this smaller and I'm going to color this in like I always do. All right. So hopefully so you know that hat symbol, right? That means to power off because there's no way of me representing that easily. So hopefully you know that just means 2 to the power n. Okay, get it? Okay. So you're talking about bits borrowed. Ooh. So if so bits borrowed for what? Bits borrowed. Okay, bits borrowed for the subnet mask. Really, that's what it means. So if you look at this, the default IP address is a Class C and has a /24, has that subnet mask so that it is NNNH. So when we borrow bits to convert this to multiple networks, we are borrowing these bits from the host portion to turn into network portion bits, aren't we? So really, what this can be represented as is, instead of these capital N's and capital H's, this is really, that's 6, I think, 8 little, well, each of those large N's or large H's is really 8 little bits, isn't it? So therefore, what we're saying here, bits borrowed, is we're taking the host bits and we're making them into network bits. So we're going to convert some of these host bits and we're going to make into network bits. So we'll work out how many of those bits we need to do in a second. But let's actually take that formula. And we said that our example is that we want to end up with 5 networks, right? So just like if you go to the shop and you have a party of 10 kids and you want to go buy some Kit Kats or ice creams and they only come in a packet of 8, how many packs are you going to buy? If you got 10 kids in the party and you want to go buy some ice cream and they come in packets of 8, how many packets are you going to buy? 2. Well, 2 is going to give you 16 ice creams, right? But you need at least 10, so you can't go less than 2 packs. You definitely have some left over, but you're not going to go less than 2 packs because you're not going to leave any child without an ice cream, right? Just like in this case, you're not going to leave any computers without an IP address if I need. So you're not going to have not enough networks because in this case we're looking at the number of networks. So we want 5 networks, but you need to have at least 5. So really, it's 2 to the power of n equals the number of networks. So let's put it here. So number of networks is 5 equals 2 to the power of something. N is something. It's a variable, right? So if we look at that, 2 to the power of it, we've got all these 2 to the power ofs here, don't we? So if 2 to the power of 0 is 1, 2 to the power of 2 is 2, and so forth. 2 to the power of what is going to give me enough networks if I need 5? 2 to the power of 3, right? Gives me 8. So really, like the ice cream situation, we're not going to have less than 5. We need at least 5. So the closest one to be 5 or above is 8, isn't it? You get me? Okay, we're not going to fit exactly in this situation, but we're going to have at least 5. So really, this thing changes now to 8 equals 2 to the power of 3. Remember what n stood for? N is the bits borrowed. So n is in the same position, isn't it? So n equals 3. You get me, guys? N equals 3. If n equals 3, n equals the amount of bits borrowed. Okay, amount of bits borrowed. If we go to this host portion, remember we're borrowing the host bits and making them into network bits. These are already network bits, so we can't borrow those. So we've got to start here. And we'll always start from left to right. So therefore, 1 bit, 2 bit, 3 bit. They now will become little n's. You get me, guys? Well, this is kind of funny. So what kind of slash notation is that going to be? So remember what the slash notation is, the cider notation? It's a sort of slash something a number. What is that going to be? Slash 27. Remember what I said about the slash notation is how many bits is going to be the subnet mask or network bits. Okay, so if we are turning those extra 3 bits into network bits, it's really 8 plus 8 plus 8 gets us 24, which is what's there by default. And then we're going to add 3 more bits, which gives us 27. Are we all good? All right. So what is the new subnet mask now? So if you remember, we had a definition of what the subnet mask is, right? Subnet mask is where all the network bits are equal to 1 and all the host bits are equal to 0. So let's put that right here. So that's what we said before, didn't we? Okay, so therefore, if we just look at that last octet now, because these ones are pretty obvious, that's going to be equal to 255.255.255 because those ones are full, right? Those octets are full. But it's that last one that's a bit funny. So we know that that's what's the first 3 octets is going to be. Let's look at just this last. Let me see if there's more. No, I thought there might have been a way of actually highlighting it, but let's just do it like that. All right, so let's just copy this and we'll put it here. Okay, we'll put it here. So if you think about it, just that last octet, it's going to be n, h, 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 h. So we'll get rid of the formatting and we'll change the colors. So no more bold, and we're going to change these to black because that's what we've been doing, and change these to red, which is what we have written here. Okay, all good? So let's read this again. Subnet mask is where all the network bits equal to 1, where all the M bits equal to 1. So M bit there. Sorry guys, I noticed that this is again not formatted properly. So we'll just put the normal automatic. So all the M bits, that's an M bit, that's an M bit equal to 1. There's no more N's, right? And all the host bits are equal to zeros. That's a host bit, that's a host, that's a H, oops, H and H. So far so good, agreed? So if we now convert this to a number, if we convert this to a number, so let's make that red as well, just keep our continuity. If we convert this now to a number, we know how to convert binary to decimal. We just add the value of the column multiplied by the column for all of them. So it's 128 plus 64 plus 32 plus 0 plus 0 plus 0, which are all zeros anyway. So what would that be? 192 plus 64 is, 128 plus 64 is 192. Plus 32 is 224, right? Right, so let's not highlight that. Let's make that. So basically what that is saying to us is now that last octet is 224. Okay, you see that that's a subnet mask now, isn't it? That's a strange subnet mask. We haven't seen this before, but we got it because of that. All right. So now I'll give you another. Now we have to actually generate the 5 networks. It's saying we're going to end up with 5 networks, or 8 networks, in fact. So now, how do we generate the networks? I'm going to give you another definition now. I'm just going to paste in here. The multiplier is equal to the value of the column of the last borrowed bit. Okay, so M, we're going to call it M, equals. And if we look at the last borrowed bit, we borrowed from left to right. So it's not, this is not the last one. This is not the last one. This is the last one. Ding, ding, ding. This is the last one. Okay, so we might just highlight that somehow. We might just go make it bold. No, that's not highlighting enough. And we'll make it, no, that's too much. Let's make it, that's red is too. Can you see that? Now let's just make it. That's not really, it doesn't stand out too much, does it? So we might just change the thing a little bit. I was hoping not to get away with that. Okay, so that is the last borrowed bit. So what's the value? So let's read the definition again. The multiplier is equal to value of the column of the last borrowed bit. This is the last borrowed bit. What's that value of the column? 32. So M equals 32. Okay, how do we generate the networks, or work out what the networks are? I'll give you another definition. It's full of definitions here. To generate the networks, sorry, I'm just trying to make this read a little bit better. To generate the networks, we start with the network ID we first determined, then we add the multiplier to the octet of the borrowing. So let's start with this. This is the network ID we first determined, didn't we? Okay, so network ID. All right, so that was 192.198.16.28.0. And where do we borrow the bits? Which octet did we borrow the bits? The fourth one. So this is the octet we made the borrowing. So let's leave this a little bit and we actually go. Okay, let's go to the next one. So the next network, okay, so I've left some room for other things later on, but the next network is going to be this number plus the multiplier. Okay, so that's the octet that we did borrowing from, and it's a 0 to start off with. And if we look at this, we add the multiplier to the octet that's of the borrowing. So the next network is going to be 0 plus the multiplier, which is 32. It's 32. Let's copy this. The next network after that, and I'll next one after that, next one after that, and we need 5, but we're going to get 8, aren't we? We could just keep on going on to the numbers. So 1, 2, 3, 4. Sorry, let me count. 1 network, 2 networks, 3 networks, 4 networks, 5 networks, 6 networks, 7 networks, and then finally the 8th network. So again, the multiplier is added to the octet of borrowing. So the next network after this one is basically going to add 32 to the previous network. And what's that? 64, correct. And the next network is going to be what? 64 plus 32, 96, not 128. You're not doubling it. You're adding the multiplier. Okay, remember what I said? Add the multiplier to the octet of borrowing, not doubling it. Okay, so you've got to follow the rules we set aside. So what's the next one? Now I think you're on the thing. So 32, 128, did you say? And what's the next one? 160 or 192, and then 224, what's it? Okay. So you can see these, we're going to end up with 8 networks because obviously we said we're going to get 8 networks. There's a couple of things, okay? So if you remember, we said that this is a network ID. We said there's always a broadcast, isn't it? For each network, there's a broadcast IP address. So the broadcast IP address is basically the last IP address that's on that network. Well, the next network is here. The broadcast is just before it, one before it. Okay, if you want to think about it, if this is a block of land and I'm gonna subdivide the land, and this room's the land, I'm gonna divide it here. So this up past this point is going to be the next lot of land, but before this point is going to be the last part of my land, right? So you got to think about that. So just before the next network is my broadcast. What's that? So obviously the network part is all the same still. What's going to be the broadcast IP address? 31, correct. It's one before the next network. All right, but we also said that, what about the IP addresses we use for the computers? We said the first usable address, and obviously we've got a last IP. What's the first usable IP address? Yeah, the first one is one after my network, isn't it? .1. It's just like that's the beginning of the LAN is the network, and then straight after that is your LAN, isn't it? So that's the first IP address. What's the last IP address? 30, because it's the first one. One before the broadcast. So my range, if you want to talk about, say, range. .31, 30, sorry. I might just reduce that size a little bit more. All right, so you can see how I've worked out those bits of information, and I can now do this for each of the other networks. Okay, so do this, do this, do this, do this, and I'm sure it's going to be a little bit boring. It's going to become a little bit boring after a while, but we could. All right, let's do it. All right, so again, if we apply the same rules, the first IP address is going to be 1 after the network ID. The network ID for this network is that, so it's going to be 33. The broadcast is going to be 1 before the next network, which is going to be next network 64, so it's going to be 63. The last IP address is going to be 1 before the broadcast, so it's 62, and the range is between 33 and 62. Are we good with that? And I could just keep on going, okay, applying the same rules. All right, so there's no point me saying all this and knowing how to do all of this. The point is, can you? All right, so before we move on to the next thing, I'll just make this display everything. All right, now I'm going to give you a chance. So instead of this IP address, I'm going to give you another IP address. All right, and instead of us saying we need 5 networks, we're going to say we need 10 networks. Okay, so I'm going to delete all of these. And we're going to delete all of this because obviously that's not right anymore. And I'm going to delete all of this because that is no longer possibly it's not going to be right anymore. And we'll delete that one. And we'll leave it there. All right, so taking that IP address, work out what we just did just before. That's your challenge, and we'll work through that as a team. So I want you to be able to do that eventually. So I want you to work out each one of those things that I just worked out. And we'll and I want you to sort of generate the networks. So it's about 10 past 12. I'm going to go to the toilet, but let's regroup at 12:25. So give you about 15 minutes yourself, and then we'll work it through together. So I'll rechange this back to to clear it. Oh, that's the wrong color. Right, and we'll make that auto, and we'll clear all of this, and we shall make this again the default color. Okay, Jaden, you got your hand up. What's your question?
Is it possible that you can like maybe zoom out, or like, so I can see like to generate the networks? I should have been writing it down, but I didn't.
Yeah.
Generate the networks. We start with the network ID.
All right, let's zoom out a little bit more then.
I'll just scroll down a bit. Oh, thank you very much. Thanks.
All right, hopefully you can all see that. Yeah, so yeah, definitely should be writing it down, because obviously there's a reason why I've put those things there, is to help you try to remember the process. So I'm going to go to the toilet now. I'm going to leave this on the screen. If I lock my screen, can you still see it? Let me see. Can you still see it? No, okay. So in that case, I'm going to trust you guys not to mess with my computer, because it's not good practice that I lock my that I don't lock my screen, but I also need to leave the room to go to the toilet. So if anyone touches my screen, I'll never undo what I'm doing now, because I'll be breaking the rules of TAFE. So please don't let me lose that trust.
Hello, Alex. I can't see it.
So don't put this in the flash. Yeah.
Alex,
Hmm?
you can have a look and tell me if I'm understanding this.
In a second, we'll be going through it anyway, okay? So hopefully you can check for yourself then. So it'd be 1 more minute anyway, we'll be going through this together. So if you get the same answers as me and the logic is the same, then you're right. If you're not, then check where your logic may have broken down. All right, guys, so I'll get you to pay attention now. So if you got it, that's great. If you don't have it, pay special attention right now. All right, so I'm about to go through it. So Jaden, are you needing to ask a question before we go through or after we go through it?
Oh, that's right, thanks.
Okay. So again, if we start off with this IP address, yeah, hopefully you'll realize that's a class C again. So we're sort of being consistent. And the default subnet mask, if it's class C, again, is 255.255.0, which is equivalent to /24. So if we know that, then we know that the network ID or the default network ID of this IP address is 220.62.31.0 because obviously we're doing that Boolean AND that we've been talking about. And if it's a class C and with that default subnet mask, our broadcast is going to be 220.62.31.255. And the number of hosts for class C is always 254. And the slash notation is /24. Oops. Okay. /24. Okay. And then obviously if it's class C, same as before, it's going to be n.n.n.h. I think, sorry, dot h. And if you remember, the dot h or the last octet is where we need to do the borrowing in a minute. Okay, so our question was we need 10 networks. So 10 networks, we go to our formula. What's it? Networks, number of networks equals the 2 to the power of n. So 10 equals 2 to the power of n. So just showing my working outs. And then, like we said, if we got 10 kids and we've the ice creams comes in certain size packets, we're not going to buy ice cream for 1, 2, 4, or 8 because that's not good enough. But we need at least 10, so we're going to go for 16 now. So 2 to the 4 equals 16. So really, this becomes, we need to have at least 10, but we can have a little bit more to accommodate the 10 and plus a little bit more. So equals 2 to the power of 4. So n equals 4, because if you look at that, 2 to the power n, 2 to the power 4, that's in the same position. So that's the thing that we're trying to work out, and n equals 4. So far, so good for everyone? All right, good. So if we look at this, the definition of n is the number of bits borrowed. And like I said, if we have a class C, the only part we can do the borrowing is converting the host bits into networking bits. So we will have 8 little H's. I might zoom in a little bit now because I think we're just looking at this one. 8 little H's by default. But we need to borrow 4 bits. So therefore, I'm going to go 1, 2, 3, 4. And we're going to turn these little H's and little N's, which will make black again. All right, so N's. So if we're talking about this table now, so this is going to be if we look at that last octet, it's going to be N, 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 H, 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 and obviously these two becomes that black. And basically, if we look at our subnet mask, the definition of subnet mask, it's where all the n bits are equal to 1 and all the h bits are equal to 0. So wherever there's an n, we put 1, 1, 1, 1, and wherever there's a h, we put 0, 0, 0, and 0. Hopefully that's not upsetting anyone. Okay, so what is that as a subnet mask? That is basically we convert this binary number into a decimal number. It's 128 plus 64, 192, plus 32, 224, plus 16, 240. And so therefore our subnet mask, our new subnet mask, is going to be 240. And our slash notation, it's obviously we've got 3 times 8, 24, plus 4 more, 28. Okay, so far so good for everyone. Any questions thus far? Pavel, you were saying check your work. Are you checking out what is it exactly the same as what you're getting?
Yeah.
Okay, good. Okay, so that's good. We've worked that out now. That's the new new information. Okay, so that's the new subnet mask. Sorry, I shouldn't have changed that, but /0. But the new subnet mask is going to be /28, which is equal to 255.255.255.240. All right, that's the new information really now. Okay. Then we had this thing called multiplier. Multiplier equals the value of the column of the last borrowed bit. So M equals, okay, so the last borrowed bit, that's not that one, not that one, not that one, this one, because that's the last N. Okay, that's the last bit that's converted into an N. So now that becomes our, our multiplier, the value of the column. So M in this case equals 16. And then it says to generate the networks, we take the network ID we first determined, then we add the multiplier to the octet of the borrowing. So if we actually look at our network ID, the first network ID was this. That's what we determined from our information we were given. So 62, 31, 0. And we might just copy this all the way down because we need it. So we'll go and go all the way down. Yeah, I think that's okay. All right, so that's all the same. Then we said that that's the first network. It's always going to be 0, okay? It's just what we start off with here. And probably most likely always going to be 0 if it's class C in that area. Okay, so add the multiplier to get the next network. The next network, what's our multiplier now? 16, right? So what's 0 plus 16? 16. What's the next network? 16 plus 16, 32. And the next network is going to be 48. Next network is going to be 16 plus 48, 64. And you notice that these are all those sort of binary numbers that we sort of used to. 16, that's 80. And the next network is going to be 96. Next network is going to be 112, I believe. Yep. And then obviously we can keep on going, but I'm not, because it's going to be lots and lots of networks. We're going to end up with 16 networks, really. Okay. So the first IP address is 1 after the network ID. So 0 plus 1. The broadcast is 1 before the next network ID. 16 take 1, 15. And the last IP address is going to be 1 before the last IP address, which is going to be 14. And the range equals basically 1 to 14. Obviously, we're talking about the last octet here. Are we good? Did everyone get the same results? If you didn't, then it's probably something that you need to brush up on. Because in your assessment 2, we'll be dealing with subnetting, not maybe to the extent that we're doing here, but it's a little bit. All right, so hopefully you've got the knack of finding out networks to IP address, networks, number of networks. But what if the question is not about the number of networks? What if it's about the number of hosts? Okay, so let's change this back now to what was default, which was 24 and 0. All right, so let's keep this one. We'll change these colors back to what we had before, and we'll change these ones to yellow and what we had before. Then we'll delete this, and we'll basically delete the contents of this. All right. So what if the question is, instead of we need 10 need 10 networks, we need networks what if we need networks to have 30 so let me just format this a little bit better. What if we needed networks to have 35 IP addresses on each, or 35 hosts? Okay, so instead of IP addresses, we'll put that host, which effectively is the number of IP addresses. Get me, guys? All right, so the question is, we need networks with 35 hosts or IP addresses. So I'm going to give you another definition now. So this was the number of networks. So we're going to give another definition now, and I'll just put it down here. The number of hosts equals 2 to the power of n minus 2. Ooh, not 32, 2. Where, sorry, not n. We'll just do different thing. We'll do h, where h is the number of host bits remaining. Okay, write that down. If you're not writing it down, write it down, because again, this is stuff that you need to remember and sort of use later. I'll make that different color, and I'll highlight this. All right, so it's very similar to the other formula, isn't it? But you notice that there's a -2, -2. Why do you think there's a -2? So?
Reserve the network and broadcast.
Yeah, exactly. Every network has to have an IP address for the network ID and one for the broadcast. Exactly. That's why there's a -2. Okay? But it's pretty much the same formula. So it's not very hard to remember. Okay? That's why I sort of am typing it out off the top of my head, really. Okay? And because I understand the fact that it needs the -2 because it's a broadcast and network ID, then I can remember the formula quite easily. All right, so now we're going to change this one to, instead of being n, it's h, right? That's the variable. So now we'll take this one, we'll delete that, and again, everything else is the same because it was starting with the same IP address. It's a class C, that's the default subnet mask, that's the network ID, that's the normal broadcast, and that's the number of hosts we can have on the network initially, and that's basically the slash notation, and that is the arrangement of the network and host portions by default. So let's take this formula. We'll go, we'll type the formula out here again, because I want it to, where was it? I put it here, didn't I? All right, so number of hosts equals 2 to h minus 2. So obviously it's 2 to the power h, not h minus 2, okay? So if that could be a little bit confusing if you don't know what I mean by that. Okay, 2 to the power h, then minus 2. If you want me to be more correct, like that, okay? Do you get what I'm saying? All right, cool. Because if someone just looked at that, they would probably be thinking, what the hell is he talking about? So that's more correct if you like, 2 to the power of h minus 2. All right, So I might just quickly go here and change this one too. So okay. So now what we plug into formula, what we know, and what we know is that we need 35 hosts. Okay, 35. 35 equals 2 to the minus 2 to the h minus 2. So again, if we look across, again, it's the same binary numbers, isn't it? 2 to something. We need 35 hosts. So if we sort of straighten out this formula, it's really 37 equals 2 to the power of h. So we're looking for 37. 2 to something equals 37. So if we look across here, oh, it's again like buying that boxes of ice cream where we need 37 kids now, but they only come in these packs. So we need to sort of go to here, don't we? So really, this becomes 64 equals 2 to the power of, what is 64? 6. 6. And h, now h is equal to 6, because that's in that same position again. So h is equal to 6. We put that aside. And now we read the formula again, where h is the bits remaining, the host bits remaining. Where are the host bits? The host bits are in the last octet. So really, these are 1, 2, 3, 4, 5, 6, 7, 8 again. And the host bits remaining, there's 8 bits. And when we say remaining, remember we borrowed from left to right, so the remaining h bits are from right to left. So we go 1, 2, 3, 4, 5, 6 bits remaining. So we're talking about these 6 bits now are h bits. And so therefore, if those are the only ones remain, so those last 6 are the ones which are going to be h bits, or their remaining h bits, then these 2 bits will probably now become network bits. Okay, network bits now. So it's a different way of getting to the same thing, really. All right, different way of getting to the same thing. So if we take that last octet and we put it here, what we're going to have is we're going to, oops. And we're going to have an arrangement of network bits and host bits like that. Okay? And now, if we look at the subnet mask definition, the subnet mask is, again, where the n bits or network bits are equal to 1 and the host bits are equal to 0. So 1, 1, 0, 0, 0, 0, 0, 0, and changing these two to be the right colors. And then what's the actual what's the number? That's going to be 192. So if we look at that arrangement, we can see that there's 8, 8, 8, 24 plus 2 more. That's going to be /26, and the new subnet mask is going to be 192 for each of the networks. Okay? So I might not have been clear for that. This now is a new subnet mask for each of the networks we're regenerating. All right, so now let's do the generation of the network. So again, we've got that network ID that we started off with, which is here. But the next network ID, let's just delete all of these stuff. The next network ID is where the multiplier, oh, we haven't worked out the multiplier, have we? So something we missed. So if we read the multiplier is the value of the last borrowed bit. And that's that column there. That's the last n, last one, and the value is 64. So the multiplier is 64, and therefore we start off with the original network ID, and we go to the next network ID is 0, or the network ID, that octet, plus the multiplier, which is 64. 0 plus 64 is 64. The next network ID is going to be 64 plus 64, 128. And the next network ID is 128 plus 64 was 192. And the next network ID is going to be 256. And if we have anything that's bigger than 255, we know that's not possible, right? So we basically stop there, and all of these networks don't exist now. So really, we're going to end up with 4 networks, okay? The 0 network, the 64 network, the 128 network, and the 192 network. And all of these ones don't exist now. So if we actually do what we've done before, so the first IP address is going to be the network ID plus 1. 0 plus 1 is 1. The broadcast is the next network ID minus 1, so 63. And the last IP address we can use on this network is the broadcast minus 1, which is 62, which gives us a range of 1 to 62 for the host. All good? And then we can work out the rest of them as well. I know we're doing a lot, and we're definitely doing a lot, but you know, like you're sort of noticing I've got a lot more experience than you guys, obviously, and it's obviously hard to compare me to you guys right now. But I started at some stage in the past, just like you are starting here, and the fact that I can now do it without referring to anything and just repeating it off the top of my head, I don't necessarily need you to be able to do that, because you're not going to do a test. But if you want to do the CCNA test, you need to do this with a bit of scrap of paper, okay? With a bit of scrap of paper in front of you, maybe like a basic calculator. But if you're not doing the CCNA test, what you have to be able to do is just do the assessment part 2, which assessment 2, which is there's a bit of IP addressing scheme that you have to develop. All right, so now that I've shown you that example, I'm going to give you a chance to work it out yourself, okay? I'm going to give you another IP address now. Let's just not stuff around. We'll go 192.168, which is a private IP address range, 33.67. And I'm going to delete all of these stuff. And I'm going to delete all of this stuff. And delete that, delete that. And what I want you to do now, instead of 35 hosts, I'm going to make this number into something else. Let's do 92 hosts. That's the IP address you start off with. That's a requirement. Can you please try to do it yourself? Again, I'm going to give you about 15 minutes to try to do it yourself, and then we'll work through the answers together, and hopefully you can check yourself.
And get into me after 1 minute background. Yeah, after 1 minute. Make this out.
How's everyone going? Finished or still doing it? Finished? Okay. Let's just check our work then, okay? So let's work through this one. So again, this is a class C. So we've kept it all simple for you guys. And the default subnet mask is 255.255.255.0, which is /24 because of the 24 bits used. The network ID, if we do the Boolean AND, is 192.168.33.0. The broadcast is going to be 192.168.33.255. And the number of hosts is always going to be 254. And that's that. But the question is, we need number of hosts. So obviously, if it's number of hosts, we take this formula and we work from here. So we go, oops, let me just fix that up. We go take that formula, we put it in here, and basically we substitute what we know, 92 equals bracket 2 to the power of h minus 2. All right, so again, if we look at this, Nothing's really going to fit 92 exactly, but we need at least 92. So 128 is a good number because 64 is not enough. So now our formula becomes 128 equals 2. Sorry, should have done that a little bit before that. So 94, if we simplify that equation a little bit, equals 2 to the power of h. And then we know it's still the same thing, 128 equals 2 to the power of 7. So h being that same position equals that 7. And then we write that down and we read the definition of h. H is the bits remaining. So if we look at this, the default network portion is n.n.n.h, which is 1, 2, 3, 4, 5, 6, 7, 8 h's, and it's saying 7 h's. Let's say h equals 7. 7 h's remaining. Okay, number of host bits remaining. So 1, 2, 3, 4, 5, 6, 7. Those bits are going to be remaining h bits, and this one now becomes a network bit. So we're getting that. So the format of the last octet is going to be n h h h h h h h, and that one being read now too. And our subnet mask is where all the n's equals 1 and all the h's equals 0. And our new subnet mask, if we convert that into a binary number, it's really easy, this one. Our new subnet mask is going to be 255.255.255.128, which is equivalent to /25. So all our new networks will have that subnet mask. And how do we generate these networks? We need a multiplier. In this case, the multiplier is the value of the last borrowed bit. There's only one bit borrowed in this case, so that is this column here. The value is 128. So m equals 128. And we need to generate the networks. So to generate the networks, we take the original network ID, 192.168.33. Sorry, I'm writing it wrong. 168.33.0. And we'll just copy. Actually, I wonder if I can just go. I think that's it. Yeah, we can do that. That's good. That will make my life a little bit simpler. And we just, so we go to the next network. So this is the first network. And we go to our next network ID. It's the previous network plus the multiplier. 0 plus 128 is 128. And we go to the next network now. 128 plus 128, 256. And like I said, if you've got anything above 255, that means it's not going to fit. So that really means that network doesn't fit. And really, we're going to end up with two networks of 120 something hosts on each one. So how do we know? Well, we have a broadcast. The broadcast is one before the next network next network ID. Our first usable IP address is 1 after the network ID, which is 0 plus 1. Our last IP address is 1 before the broadcast, 126. So our range is from 1 to 126. And if we do the same thing, the broadcast here is 255, 254, and 1 after the network ID is 129. And then if we actually work out the range for this network, it's going to be from 129 to 254. Okay, between those two IP addresses. Okay, So there is a lab for calculating IP subnets. There's a packet tracer for subnetting on an IPv4 network, and there's a subnet scenario. And next week, what we're going to do is we're going to look at the VLSM, because I want to we don't have enough time today to cover that, but that's what we'll need for our assignment 2. Okay, so have a look at these labs and packet traces, and please work through them, and obviously try to get them done.